Stiffeners at 1/3 points of a steel beam. Stiffeners at the 1/3 points of a steel beam are provided to prevent web buckling or crippling, and they are typically used when to provide 1/3 point stiffeners. Concentrated loads at 1/3 points. If the beam carries significant point loads at or near the 1/3 spans, like in bridge girders, crane girders, or beams supporting equipment, the web may experience local crippling or buckling at those locations. Long spans or deep beams. For beams with slender webs, high depth to thickness ratio, intermediate stiffeners are often required at intervals 1/3 points being common, especially if web slenderness exceeds code limits. High shear near third points. In continuous or indeterminate spans, maximum shear often occurs near the supports and 1/3 points, and the web may need reinforcement to carry the shear without buckling. Bridge girders and plate girders. In these applications, intermediate transverse stiffeners are typically placed at 1/3 points to maintain the stability of the web under both shear and compressive stresses. Why use 1/3 point stiffeners? Prevent web buckling under shear, compression from point loads or reactions. Improve load distribution, they help distribute concentrated loads through the beam depth. Control deflection and vibration in slender beams. Required by design codes, e.g., AISC or Eurocode, when certain geometric and load criteria are met. Span versus need for 1/3 point stiffeners. The need for stiffeners at the 1/3 points is not strictly determined by span alone, but span can be a contributing factor, especially when combined with web slenderness, point loads, and shear demands. Guideline by span, in meters. Span: consider 1/3 stiffeners when 5 m rarely needed unless heavy point loads are applied. 5 to 10 m needed if there are concentrated loads or slender web. 10 to 20 m common for plate girders or heavy loads, 1/3 point stiffeners often required. 20 m almost always needed, especially for bridges or long span structures. More important factors than span alone. Web height to thickness ratio, H/TW. Magnitude and location of point loads. Shear force near the 1/3 points. Lateral torsional buckling concerns. Design code provisions, e.g., AISC 360, Eurocode 3. Universal column, UC, beam stiffeners. Whether stiffeners are required for a UC, universal column, beam depends not just on its size but on the loading conditions, support conditions, and especially the slenderness of the web. When do stiffeners become necessary in a UC beam? High concentrated loads are applied close to the web. Web slenderness ratio exceeds code limits. Shear force is high, causing web buckling. Bending and axial interaction occurs. You're using the UC as a girder in long span or heavy-duty applications. 2 web slenderness thresholds. Codes like AISC or Eurocode 3 flag stiffener requirements based on the web slenderness ratio. Web slenderness equals clear web depth between flanges/web thickness, where HW equals clear web depth between flanges. TW equals web thickness. Rule of thumb. If web slenderness 40, Eurocode, or over 60, AISC, web is slender, and stiffeners may be required. 3 examples, UK sizes. UC section H_W/T_W need for stiffeners. Dash 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 152x 152x 23 UC 30 usually no. 203x 203x 46 UC 25 rarely needed. 254x 254x 73 UC 22 no, unless heavily loaded. 356x 406x 235 UC 17 no, very stocky web. 356x 127x 33 UB 50 yes, possibly stiffeners needed. Conclusion. UC beams rarely need stiffeners at 1/3 points unless there are large concentrated loads at those points, or you're using a slender section, or the beam is deep and lightly webbed, unusual for UCS, more typical in UBS or welded plate girders. Example, 305x 97 Depth, 307 mm. Web thickness, 11.2 mm. Clear web depth, 260-270 mm. Web slenderness, 24, compact. Verdict, for a 305x 97 at 1/3 points are not required under typical beam loading. Only needed under large concentrated loads, high performance design, or abnormal conditions.